I'm going to be presenting about Performer, a Python implementation of the essential features of MaxMSP. The target audience for this package are people who are already familiar with Python getting into digital music, but also people who have been in digital music working with Max, making it an easy transition into using this Python package. It is more versatile and expandable than MaxMSP in the sense that you could use any Python package with it instead of waiting for someone to write wrappers for these packages to work in MaxMSP. And it also just makes sense for digital instruments because a common pipeline is using an Arduino to send sensor input into Python. Python processes them and sends parameters to MaxMSP, and removing that last chunk would be very helpful in debugging. The implementation uses NumPy for matrix operations, and all audio buffers are matrices. I use low-level bindings with the C library for handling audio, and we have a control queue that handles processing priority, and that way makes sure that audio is never delayed and there's no clicking in the sound. And I also implement signal and MIDI processing. This is what a typical hierarchy would look like. You have an audio out object that manages everything under it, from oscillators to MIDI inputs and MIDI outputs, and all of this is handled by the audio out objects queue. This is a simple example of summing multiple LFOs controlled by a MIDI keyboard. One thing that Performer does is also handle MIDI inputs and outputs. So in here I'm going to create a virtual instrument in GarageBand. And once I go to my script, I could add a parameter, MIDI out equals true, that specifies to spit out MIDI out information. And once we run this code, it will automatically be discovered as a MIDI input device. MaxMSP and Pure Data both have amazing infrastructure for handling audio and a lot of optimizations that they use, and I borrow from both of these. They also have standards for signal flow that seem intuitive to people who are already in digital music. What they do is they have inputs and outputs, and everything is a top-down control flow. On the left, you can see an example of a top-down view with inputs and outputs. You can see we generate two LFOs, sum them into a sum block, and then input them into an ADSR with an output of an audio. And this is what MaxMSP would look like. On the right, you could see code that does it in an object-oriented way, where you have an audio out object and an ADSR object that has two properties, which are two LFOs. And the ADSR has a property, which is the audio output object. One challenge has been designing for unknown inputs. Inputs can have multiple types, and we don't want to restrict them, and these types might be things that mutate over time, so we need some way to keep track of changing parameters. This all happens in the audio out's queue routine, where it is smart enough to know whether an object mutates or not, and know at what rate to update it so that it updates fast enough but does not slow down everything. This is different from Pure Data and MaxMSP because all of inputs have two types and updates are propagated through bangs, except in this case, state propagation happens automatically. Also, MaxMSP has no queue management in their implementation, and this makes it very expensive to put different signals in sync. One open question is how do you convert existing structures in Python into controllers and use them efficiently? And traditionally, in MaxMSP, we use bangs to propagate states. In Performer, we take inspiration from common existing structures in Python and turn them into queue manageable updates. Here's an example. On the left, you can see some code that tracks faces. On the right, you could see how the addition of 4 lines changes this code into a computer vision powered theremin. This is the CV theremin in action. Working with audio at such a low level is challenging. One thing is optimization is key. You want consistent runtimes between function calls. Managing threads is also important. You can't have visual elements delay audio buffers, for example. Pre-computing functions using wavetables and fixed length storage buffers is also essential for this implementation. I also learned a lot of interesting things, like frequency modulation bands evolve over time and you don't see all the harmonics appear all at once, and the way you fix that is by using a randomizer for the starting index. Wavetable indexing is not as easy as just read things faster when you have to deal with things like the sampling rate, and phase matching algorithms are very hard to do, especially when phase matching starts taking time and delaying things out of phase. The next steps would include implementing more fun audio modules. Right now I only have the basics for synthesis, so things like generators, envelopes, and ways to operate on them. It would be interesting to implement things like the Starlight module. Another thing would be studying controller interactions better, and that can hopefully help me simplify controller objects and make them such that they're truly plug and play. And adding a way to import Max modules into the package would truly increase the value of this package, making any Max patch that already exists compatible with Performer.